We originally defined acids as containing the hydrogen ion, and bases as containing the hydroxide ion. In reality, both acids and bases contain both of these ions. This is because water itself actually slightly dissociates into hydrogen and hydroxide ions. A solution is considered acidic if the concentration of the hydrogen ion is greater than the concentration of the hydroxide ion. A solution is considered basic if the concentration of the hydroxide ion is greater than the concentration of the hydrogen ion. If the concentrations are equal, the solution is neutral. In science, the lowercase p is actually a function that means you take the negative log of whatever comes after it. So pH means that you take the negative log of the concentration of the H+ ion. Let's review changing between logarithmic form and exponential form from math. The base of this log is b. So to convert this to exponential form, it means the base b raised to the y power, what the logarithm is equal to x. And we can use the same format to convert between the concentration of H+ ions and pH. So, since there's no base written in the log, it's assumed to be a log of base 10. The one thing we do need to watch out for, though, is the negative sign. The first thing we need to do is get the negative sign over to the pH. So if we multiply both sides by -1, we have negative pH is equal to the log. Again, no base is written because it's assumed base 10 of the concentration of the H+ ion. Now we're going to do the same thing that we did with the original log equation from the previous slide. 10 is the base, so 10 raised to what the logarithm is equal to, which is the negative pH value, is equal to the concentration of the H+ ion. And this is true for any solution. If we take that information, we can figure out very quickly that something with a pH of 7 has a concentration of H+ of 10 to the -7 molar. Something with a pH of 6 is 10 to the -6, pH of 5 would be 10 to the -5, and a pH of 4 would be 10 to the -4. We fill in the rest of this table, 10 to the -8 for a pH of 8, 10 to the -9, and 10 to the -10 for a pH of 10. Relative acidity is talking about how acidic something is compared to something else. In this table, we're going to be comparing everything to a pH of 7. Since it's the H+ ion that makes something acidic, we're going to look at the concentration of the H+ ion to determine how acidic or basic something is compared to a pH of 7. A pH of 6 has a concentration of 10 to the -6, and a pH of 7 is 10 to the -7. So how many times more concentrated is the pH of 6 than the pH of 7? 10 to the -7 times 10 gives us 10 to the -6. So 6 is 10 times as acidic as something with a pH of 7. 10 to the -7 compared to 10 to the -5, we would multiply something by 100. So a pH of 5 is 100 times as acidic as a pH of 7. And 4 would be 1,000 times as acidic. So we're going to keep adding a 0 for every step in pH that we decrease. However, if we're looking at something that's more basic, it should be less acidic. So instead of 10 times, it would be 1/10 as acidic, 1/100th, and 10 would be 1/1000th. Again, we're adding 1 0 for every step in pH that we're changing. Basicity is the same idea. If something's more acidic, it's less basic. So if it's 10 times as acidic, it's going to be 1/10 as basic, 1/100th, and 1/1000th. If something's a 10th as acidic, it's 10 times as basic, 100 and 1,000. Again, keep adding a 0 for every step in pH. This question says, I have a solution with a pH of 4 and it has its H plus concentration decreased by a factor of 10. What is its new pH? The solution starts with a pH of 4. The H plus ion concentration is decreased, meaning it's becoming less acidic, so the pH must be going up. Since it's a factor of 100, it will go up 2 steps in pH, 1 step for each 0 in the factor. So starting with a pH of 4, we want to go up 2 steps. 4, count up, 1 is 5, up the second step is going to be 6. So the new pH of this solution would be 6.